Mid-century engineering relied on drafting tables, T-squares, and graphite. Every line was drawn by hand, making the design process intensely slow and physical. Computer-aided design, or CAD, removed the physical erasers and rulers. It allowed engineers to draft geometric shapes on a screen, rapidly accelerating how quickly a concept could be drawn. But as these digital files grew, they created a new bottleneck. Highly paid professionals now spend hours on non-value-added data janitorial work. These tasks include manually updating title blocks, purging unused layers from a file, and individually counting hundreds of components across a massive schematic. The transition to screens solved the physical drafting problem, but trapped engineers in a modern grind of repetitive, manual data entry. As infrastructure projects scale up, this manual duplicate and edit workflow directly multiplies both inefficiencies and the risk of human error. Over 70% of long-time AutoCAD users bypass this bottleneck by using a built-in automation layer every day. AutoLisp, a specialized programming language embedded in the software, cuts repetitive design tasks by up to 80%. It moves the user past simple keyboard shortcuts. An engineer can stop manually drawing digital lines and instead programmatically generate entire design solutions. AutoLisp is a direct descendant of Lisp, the second oldest high-level programming language still in active use today. Lisp is an acronym for List Processing. Created in the 1950s by John McCarthy, Lisp was originally designed for early artificial intelligence research. It was built specifically to process nested lists of logic, rather than just crunching standard numbers. In 1986, software developer David Betts adapted this AI-focused language and embedded it directly into the architecture of AutoCAD. Today's CAD users wield a 1950s artificial intelligence framework to build 21st-century infrastructure. How exactly does a text-based code physically manipulate a three-dimensional geometric shape on an engineer's screen? AutoLisp treats CAD geometry as a hidden, text-based database. AutoCAD uses a structure called an association list. This list pairs an internal group code with a physical property, linking text to a coordinate, layer, or radius. AutoLisp acts as an embedded interpreter. It reads these association lists, calculates new values, and overwrites the text in fractions of a second, causing the geometry to instantly expand or move in real time. Mastering the association list gives engineers absolute control over the data beneath their designs. They move from being painters on a digital canvas to architects of the software itself. Many modern programming interfaces require external compilers and dedicated software engineering degrees to operate effectively. Because AutoLisp is embedded, an engineer can type a single line of code directly into the CAD command prompt and watch the geometry instantly change. In civil engineering, a single script can instantly triangulate and map hundreds of land subdivision parcels across a varied terrain. In mechanical engineering, feeding a few variables into a routine automatically generates the mathematically perfect gear profiles for a turbocharger. And in electrical engineering, it can automatically tag miles of complex wiring and extract a perfect bill of materials into a spreadsheet. With AutoLisp, the CAD environment functions as an active parametric engine customized to any engineering discipline. This technical capability translates directly into hard, undeniable return on investment for engineering firms. Custom routines replace manual configuration with automated generation, drastically shrinking the time to market for complex designs. This chart shows the impact of these automated routines. In one industry case study, a 15-month traditional workflow was compressed into just 2 days. This level of efficiency provides a massive competitive advantage for firms operating in high-throughput industries. That firm-level economic efficiency also translates into individual career value and leverage for the engineer. A standard manual drafter faces a hard career ceiling, but mastering AutoLisp facilitates the transition to a CAD manager or BIM specialist. Building information modeling focuses on managing intelligent 3D data, pushing compensation past the $135,000 mark. AutoLisp provides an engineer's path for escaping the daily grind, future-proofing their career, and maximizing their intellectual value in the modern workforce.